This is a very, very expensive piece. Is that aluminum or stainless?
That's aluminum.
Aluminum. Got it. So this is our raw material, and we're gonna go make a rocket. Okay. That's a unique dimension. You normally don't see plates of aluminum that wide and that long.
No. So this is actually made especially for us in these dimensions.
Okay. So you're tooling up an entire foundry of some type, or a rolling mill.
A rolling mill.
Okay.
So starting here with the raw stock of 7000 series aluminum, it'll eventually become a round rocket barrel. This is just after machining.
So how long does it take to machine that? You have the tools here to machine this isogrid.
Yeah, this is about a 2-day operation altogether.
This is not something I expected to see. These guys they appear to be are they washing? What are they doing?
They are. So the first thing that happens to those big plates is we plane them. We make them flat. And so these guys are going over an operation that's just been done. They're cleaning it up. They're looking for any imperfections. Like these guys, they're going to go over every inch of that thing and make sure that the automated machine that planed it didn't leave any features we don't want. So you can see way down there where the cutting head is. These are actually the plates for Vulcan Flight 2.
So these machines are CNC, correct?
Yes.
Okay, and are these specially made machine, or are these, because usually you don't plane a surface that wide?
No, generally when you're in this kind of factory, you're going to see tooling that comes from big tooling manufacturers, but it has been designed especially for this application. So all of this is custom stuff.
Really?
This factory was actually built with the idea in mind of building as many as 40 rockets a year. And so we have so much capacity, it's easy for us to kind of make up for little challenges like that along the way. Because nowadays you fly maybe 12 or 15 times a year tops.
Right. Okay. So you're not at capacity?
No, not even close. We were looking at isogrids down there and we were looking at those delta panels. So if you look at this panel that's being machined, you can see that they're rectangles. So this is an ortho grid, which is not symmetric.
So these are Vulcan?
Yes, these are Vulcan panels. These panels are going to space.
Wow, it's got a lubricant on it, it feels like.
From the machining.
Got it. Got it.
These are the panels that have been machined, they've been cleaned up a little bit, and they're getting ready to go into these 25-ton brake presses, bump presses, in order to potato chip them up into a curve. So you can see that these guys actually have a little bit of curvature along their length. We're going to actually take that out. That helps us form the curvature along this axis more evenly. So it's sort of an intermediate manufacturing step, if you will.
Is it done on purpose, or is it a function of stress relief?
It is done on purpose.
Oh, okay.
Yeah. Gotcha.
Okay. So at some point you have internal stresses in the material.
Yes.
How do you have an oven here to anneal?
No, we let them what's called artificial aging of aluminum. So 7000 series will do that. The sort of room temperature artificial aging does is even that out for us. It takes 5 of these to make a complete barrel. And what the technicians are going to do, our craftsmen are going to take one of these big flat panels on these roller carts, and they literally have patterns that are pre-formed that we've made, and they're going to roll them in and out and have that knife edge come down and hit it and slowly potato chip it up while they're matching it to the physical pattern until they have it just right. And so we saw all this high-tech computer-controlled machining down there. Now this is pure craftsmanship, where they're going to do it by eye and by pattern.
Oh, it's pressing now.
Yeah, so you can watch and you'll see. They're lifting it a little bit. He's bumping it again. So now they're making another adjustment and they're going to bump it again. This is all done by eye and by hand. Okay, so now we're in one of the world's largest plating facilities, or chemical processing facilities, where we're going to etch the panels down so that we have a very consistent, high quality known surface. and then we'll anodize them, which is plating to create a very thick oxide layer to give the aluminum corrosion resistance and a little bit of hardness. But we don't get very good corrosion resistance naturally, especially from a 7000 series aluminum, because it's not very thick and it tends to be porous. And so that's why we anodize it.
That's bad for fatigue, right?
Yes.
Okay.
Yes, very bad. So we can get a phenomenon called stress corrosion cracking, for example, if we allow corrosion to be present in these kinds of materials. This is really for cleaning, because we're gonna, there's a lot of machining activity, there's a lot of chemicals that are gonna be involved, and so we like to have a known condition when it goes in and out of the tanks. So you're looking at us rinsing and washing a ring before it comes further down into this booth, which is actually an inspection booth.
Gotcha. So this is pre-anodization.
Yes.
So this is a vat that you would dip the part into.
Yes. In fact, here we are. Here's our sulfuric acid anodization. So there's a part in there right now. It's going to sit there for a prescribed amount of time. It's heated, and then we're passing current through it, because ultimately this is actually a plating process. See, here's our DI tap water rinse we were talking about. Yeah.
So you literally put the part in there and you give it a shower.
Give it a shower.
That's awesome. Holy cow, that's intimidating.
Yeah.
That's intimidating.
Yeah, keep your hands out of it. Yeah. We'll plate, we'll rinse, we'll plate again, we'll clean, then it goes out where you were before for inspection. Here's what they look like when they come out. So you can see that sort of characteristic green bronze color of an anodized aluminum surface. And as they naturally age, it'll become more and more bronze. So when you see an Atlas rocket on the pad and you look at the booster, it has that very distinctive bronze color. This is why, because of what we just looked at here. So at this point, we finished plating, cleaning, and inspecting, and here are the panels lowered down from where we took that last shot.
And now what?
Now they're going to get friction stir welded together into barrels, forming the body of the rocket and the propellant tanks. Interesting thing, and the reason you want to do a friction stir welding is because you don't melt any material. When you friction stir weld, you never melt anything. You bring the parts tightly together and you bring a head that spins and literally stirs the material together as it moves. It never quite melts. It gets warm, it gets a little soft because of the heat generated through the friction, but we never actually erase all of its mechanical properties like you do with a classic conventional fusion welding. You literally melt the material. So now those big plates that you saw machined and you saw bent and you saw anodized have to get friction stir welded together into a barrel to form an Atlas booster. So what you're seeing here is 5, these are actually Atlas, but for the version that's Vulcan, 5 of those big panels that start out flat and thick, machined down. They're fixtured up in there, and if you look right there, you can see that sort of bright aluminum stripe that runs up it. That is a completed friction stir weld.
And you have a rotary stage at the bottom that's turning it, and so you have the weld in one side.
We're going to do 1, 2, 3. It takes 5 of those panels to make a Vulcan, so we got to do 5. We got to do all of those welds. So it'll rotate it, and we'll do another one. Rotate it, do another one.
So this is a friction stir weld.
So here's a friction stir weld, so you can feel that.
Yeah, you can feel where it heated up and grew a little bit.
Yeah. We just bring these parts tightly together. We bring a head down that spins very, very fast. It heats it, softens it, stirs it together without ever melting it, and we just run all the way down the length of the barrel. And that's how we join them together. So now we're going to look at a different friction stir welding process called circumferential, because we're going to attach a dome or a barrel. One of the things that we have to deal with is when you come around, because of the way that head works, you actually leave a terminal hole. So where you terminate, there's a hole that penetrates the tank that we then later have to seal up as well. Big tank, like the tube we just filmed, would come all the way down here, where we would either have a dome or a ring that would then get the friction stir weld to put it all together.
On the circumference.
On the circumference.
Got it. So there's 2 different operations. There's a longitudinal friction stir weld, and there's a circumferential friction stir weld.
All right, and there's an X-ray booth to X-ray joints, and then there's also a pressure booth where small bottles get pressurized, and then outside this building there's a booth where we put pressure and fluid in the big tanks to make sure everything seals.
So you build it, you weld it, you seal it, and then you take it up to a certain pressure above what you think it's going to see, and that tests it, and then you come back down and then you fly it.
You got it.